Hello everyone, this is Kashyap Mavani and this is a video submission for assignment 4. So let's get started. So this short video would be just to demonstrate how we use a CIFAR 10 dataset which has 10 categories of basic 32 by 32 color images, and how we can build a model that not only just performs on training data but also performs well on images that it has not seen before. So let's start with a basic CNN model, and notice here we will not be using regularization, we'll just make one without it. So this one is, I'm not gonna make again because it takes more time and it will make the length of the video more, but the key thing we need to see here is the straightforward CNN with two convolution layer followed by a pooling one and two dense layer at the end. We train it for approximately 20 epochs and using Adam here and a cross entropy loss. And notice we haven't added any regularization yet, so the model can easily overfit. That's the whole point of it. So if you notice here at the data that we are showing, you would see the loss from starts from 1.2 and it ends at 1.3. So right here the gap could the gap would be much more easily shown in the graph down there, which I will show you next. Just want you to keep this in mind. And then we create two basic plots, and this right here, the data we remembered, this right here shows a basic pattern of overfitting, right? This visual just shows the training versus validation accuracy loss, and the result actually in professional terms is the training accuracy goes up very nicely while the validation accuracy is going low. It stops improving right somewhere here and then it just drops. Meanwhile here the training loss goes way under, but the validation loss kind of creeps up here while going down from here and then creeps over here. So this gap essentially shows overfitting, and it also indicates that the model is rather memorizing the training images instead of learning new features to the generalized new data. So what we will do next here with the model is we will introduce dropout and L2 regularization. Now this here shows the regularization, and this we are adding dropouts as well. So to fix essentially the overfitting problem that we have with this model, we will add this too. Now what dropout does essentially is it randomly just turns off some neurons to prevent reliance on specific features, and the L2 regularization, which slightly penalizes large weights so the network stays simple in simple terms. And we also add like dropout layers after each pooling right here. So we pull, then we add dropout, then we pull, then we add dropout, right? Why we do is just to apply another dense layer and apply L2 regularization in the convolution and dense layers. So the new architect or the code essentially emphasizes more on the dropout and L2 parts, right? So after that model you would able to see this graph. Now this graph and this graph has much more cleaner consistency. So what we can see from this graph is that with added dropout and L2 the model trains more carefully. So you could see how the training accuracy is lower than before, and validation accuracy is actually more stable and overall higher than our previous model. It was right here, this one is very well up here. So this would indicate that overall the previous model had a lower accuracy and stability, and this one has higher. Basically it just means the model isn't memorizing, but it's actually just getting better at everything in general, I'm speaking. Now we'll add data augmentation. So data augmentation, what it does is rather than going for a new label data, it just shifts or rotates or add new features to the same image to make it a new data, but it's not really a new data, if that makes sense. So when we apply data augmentation using image data generation, what we do is we rotate within a range, we shift within a range, and we flip within a range, right? So this effectively creates new training samples on the fly, forcing our model to just learn new feature robustly on small image changes. So example, if there was an image at number 15, it could be changed in height at number 16. So the model would see it as a new data, but it's just the same image with a different architect on it. Once again, we will be using the same CNN architect, but we'll train with this new augmented images, right? And this one takes a lot of time compared to the other two epoch trainings. So the visualization for this one would be that the model, as it sees a variety of modified images, it further reduces the overfitting. The gap, oh my god, the gap here just shows that it reduces the overfitting. And training for this takes much longer. I'm just not doing it right now just to keep the video short. But the validation accuracy is much more steadier, and it's even better over time. So like it starts here and then it's just much more better. And the loss is the same for the loss as well. So I would say that keynote here would be that data augmentation is an excellent way to improve performance, and it's brilliant because we are not really adding any new label data, we're just using the same images. And this is just a summary of everything. There you go. And this is just a view of over parameterized model, and this is the loss for this. So I would like to conclude this with, or in a summary, I would say that at first model we saw how overfitting it was on a CFAR 10 model, which was a basic CNN, and then we reduced the overfitting using dropout and L2 regularization, which was much lower. But then we also added data augmentation, and it reduces furthermore. So together, I think these techniques just makes our model more robust, more resilient, and more ready for real world data, because all the images are not perfectly aligned as it is in a label dataset compared to the new ones that we just created using augmentation. So that's all for today. Thank you everyone. This is again Kashyap Mavani, and it's a video presentation for assignment 4. Thank you.